This video is going to cover the solving of system of equations by the substitution method. So if we have two lines that are not parallel, they intersect somewhere, and we're going to try to find out where they intersect. Substitution method is when you have y equals something and y equals something else. We can say that the two y's must be equal, and therefore these two quantities also must be equal. So 2x plus 4 and negative 3x plus 6 are each equal to y, so they must equal each other. And then we have an equation with just x's in it. So we can solve that equation, giving the x's to the left and the numbers to the right, and x equals 2/5. So that's the x-coordinate of the point where these two lines intersect. To find the y-coordinate, you can simply plug it in to either equation. I'll plug it into the bottom equation here. So y equals negative 3 times x, which is 2/5, plus 6. So y equals negative 6/5 plus 6, which is 6 minus 1 1/5, which is 4 4/5. So this says that the point of intersection is 2/5, 4 4/5. Now to check this, we've already used the second line to find, this work was all based on the second line. So the best check is to take this point and plug it into the first of the two equations. And if we do that and it works, then that's the right point. So y, which is 4 4/5, we hope is equal to, we wonder if it equals 2 times x, which is 2/5, plus 4. So 2 times 2/5 is 4/5, plus 4 is 4 4/5, which is what we hoped it would be. So that point is indeed the solution to the system. Now another problem to look at with a system of equations is where we have not necessarily both of them solved for y. But this equation is, one equation is solved for y. So we know that y equals that, and therefore that y is also equal to the complicated mess. If we substitute that block in to the top equation, we get 2x plus 3 of the y. Now it looks complicated and ugly for a moment, but the advantage of this is that the only variable in it is x, and therefore we can solve it and find the value of x. So 2x plus 3 times 2/3 is 2, so another 2x. 3 times 1 is 3, we're distributed, equals 8. 4x equals 5, so x equals 5/4, or 1 1/4, depending on how you want to write it. So, if we already know the x-coordinate is 5/4. We're looking for the y-coordinate. But this equation here tells us what y is. So if we plug it in, y is equal to 2/3 of 5/4. It's actually good to have the improper fraction while you're working with fractions, plus 1. And 2 goes into 4 twice. So 5/6 plus 1, or 1 5/6. Or if you like, 11/6. So that is the point of intersection. We used the second equation again in order to find y, so the best check is to check it in the top equation. Is 2 times 5/4 plus 3 times 11/6, is that equal to 8? Now that's interesting because we have a complicated mess with fractions, and will it come out to equal 8? Let's see, 2 goes into 4 twice, so that's 5/2, plus 3 goes into 6 twice, 11/2, equals 16/2, which is equal to 8, and that's what we were hoping it would equal. So that point is the point of intersection for the two lines. That's the idea of substitution. We're going to do some practice.